Alright, this video, I'm using a problem here that would be simpler done one way, which I'll show you, but I'm going to use it also to illustrate the way that you would do this if the problem were not a nice problem already. So it's asking us to find the area of a rectangle. It's a rectangle named ABCD, where we have these 4 points provided to us. Now, my first suggestion, anytime you see the coordinate plane pop up, anytime you have points to work with, if it's within reason, just make a quick sketch of what this would look like. So for example, here I see negative 5, 6. I'm just going to pick a point somewhere over here. We're going to call that negative 5, 6. That's our A. And then B is going to be 4, 6. That has the same height, so let's just go over to the right somewhere. Let's say that this is 4, 6. Okay, I look over here, I see negative 5, negative 2, and I go, okay, well, negative 5 and negative 5, these were the same in the x direction, so they're above each other. But negative 2 would be somewhere down here, so let's just call this negative 2. So this is negative 5, negative 2. So that's going to be our point C. And we see now that in the same fashion for negative 2, we just drop down to here. We're going to see that D is 4, negative 2. Now, the purpose of this video is going to be to show us how to find this area if this rectangle was not a nice rectangle. But I will point out that this one is oriented for us in a way that's actually really nice to see. Now, for the record, my sketch here resembles a square, but it's not perfectly square. If we notice that from negative 5 to 4, from left to right, that's a total distance of 9, where from 6 down to negative 2 is a total distance of 8. So, in general, if this was the problem you were given, realistically speaking, you would go ahead and tell me the area is going to be 72. Like, that's just a fact. That is how you would go about doing this. But I want to point out that you can use the distance formula just like we did in the last video on perimeter. The distance formula would be the way we could go about this. So for example, the side AB that we just said was a length of 9, if I wanted to find the length of that, the overall proper way, if this had been rotated and you weren't able to tell that this was a length of 9, is you would take your points. You would say, look, 4 minus that negative 5 squared, that's the subtracting our x values, plus, now in this case, they happen to be the same value. This is part of why this works out the way it does. But 6 minus 6 squared, that's subtracting our y values. This whole statement, messy as it is, would give us our length of AB. You could use a calculator here, but since I know it works out really nicely, I'm just going to point some things out. We're going to get 4 plus 5 on the inside of this. We're going to get 9 squared, so this is going to be 81. And 6 minus 6 is 0, so that's just going to go away. And so the square root of 81 would be 9. That's what we would get. So notice the distance formula does check out here. This works out. And then over here, let's go ahead and do side BD just to verify that that actually does work as nicely as we think. We're going to go in, we're going to see that we're going to do our x's, it'll be 4 minus 4. That's going to be our 0, just like we had up here with the 6 minus 6 part. And then we'll have our y components changing now, 6 minus and negative 2. And we're going to see that the 6 minus negative 2 works out really well. It's 6 plus 2. So we're going to have the length of BD is equal, so this is gone, this is just 0. It's going to be the square root of 8 squared, which is 64. And that's going to give us that square root of 8. And that makes sense because we're taking the square root of something squared. So those do cancel each other out. They're inverse operations. And so we verified here that the 9 and the 8 do work using the distance formula. And if you're still not visualizing what I mean by something that we wouldn't be able to do this way, keep in mind that I could rotate a rectangle. I could have a rectangle that goes diagonally like this. And if I gave you these points here on the corners, notice now that if this is on the coordinate plane, these aren't lined up in any nice way. I can't really measure the height of this thing because it's been rotated. Same thing in this direction. We don't see anything really that we can work with directly. What you do see, though, are these little right triangles that I'm creating by accident, or maybe intentionally, that we could use to find the lengths of these sides here. The same would be true for the longer sides. We had this really big right triangle out here, that we could use to find that length. So the idea is the distance formula takes all of that into account for you. You would never have to draw all these extra sketched in lines. You never have to draw in these triangles. But this distance formula would be helping you figure out the length of this hypotenuse by understanding the length of this height and this width here for this right triangle that we've created. So this is just my way of saying that, yes, this problem was really nice. We could have just gone in and found that 72 immediately like we did. But in problems like this one, where the rectangle is rotated, you're going to need to use this here. Please keep in mind that you don't have to do extra work. For a rectangle, you just need to know one side here and one side there, one length and one width, and you can find your area. Don't go finding all four sides if you don't need them.